Okay, for example 2, we're going to write the partial fraction decomposition of this guy. Step 1 is to make sure it's not improper. This guy is, because the degree of the top is 4, the degree of the bottom is 3. So we've got to do division. We have to do long division this time. If you need a long division brush up, I'm sure you can find a better video than this somewhere on the internet. But I've got to do x cubed times something to get x to the 4th, so that's an x. Then I multiply this x by this whole thing out here. Gives me x to the 4th plus x cubed. Draw the line, change the sign of everything because I'm subtracting. I get 0 plus 0 plus this comes down, that's a 0, that's nice. So this stuff is my remainder because it has a degree that's less than the degree of my dividend. So we can write it as plus x plus 4 over x cubed plus x squared. So what we're really saying is our original problem, x to the 4th plus x cubed plus x plus 4 over x cubed plus x squared, yikes, can be rewritten as x plus 4 over x cubed plus x squared. I'm fine with this x, but I've got to decompose this guy into simpler fractions. So step 2 is to factor the denominator. So we can't forget about this x here because that'll be a part of my answer. My answer is going to be x plus some stuff. I'll need more room than that, so I won't write that yet. But for step 2, I've got so I'm only looking at this guy, x plus 4 over, if I factor, I get x squared and then x plus 1. So I'm going to rewrite this as something over x plus 1, and the power of that is just 1, so I only need one of those, plus, here's where it kind of gets different. I need a b over a regular x, and then I need a c over an x squared, because I've got a repeated power of this linear x here. So I need a b over the first power and a different letter over the second power. So I've got to get common denominators. So this first guy is missing an x squared. The second guy, he's unusual. He's missing an x and an x plus 1 because I want it to be x squared times x plus 1. This last guy is missing an x plus 1. I also need it on the top. So this guy is really x squared plus x if I distribute. Now that my denominators are the same, the numerators must be equal. So x plus 4 equals ax squared plus bx squared plus bx plus cx plus c. I'm going to group stuff. Notice I don't have an x squared on the left side, so I've really got 0x squared plus 1x plus 4. So if I group on the right, I've got a plus b, those both have x squareds, plus b plus c, those both have x's, plus this plain old c is the only guy that's by itself. So 0x squared plus 1x plus 4 equals that. So if I match stuff up for my system, I've got 0 equals a plus b, 1 equals b plus c, and 4 equals c. And I've got to solve that for a and b and c. So c is 4, that's nice. If I work backwards, 1 equals b plus 4, subtract 4, so b equals negative 3. That's nice, so a must equal positive 3. So remember, I was originally trying to decompose this guy. I divided, so I got x. I went here. So my answer is x plus, and then we just found the numerators of my fractions. So I've got a a, which was 3 over x plus 1, plus b, which was a negative 3 over plain old x, plus 4 over an x squared. And that is my solution.